everybody. This is Joel Harris. I'm one of your presenters today. December Plant 3D User Community Virtual Meetup. We'll be beginning here in a couple minutes. Just want to let you know that here with Quentin, and we'll be starting a little bit after the hour. Welcome everybody. This is Joel Harris. I know that my audio was not working properly there, but I think that you can hear me now. So just wanted to welcome you all. We'll be beginning here in a couple minutes, maybe even shorter. It looks like our attendees are starting to taper off. So we'll be presenting to you some new stuff here in our December Plant 3D User Community Meetup. Is myself, Joel Harris, and Quentin Contreras. So it looks like we've kind of leveled off. So I'm going to go ahead and start now and welcome you all. And we'll go ahead and move on into, before we begin, making sure everybody understands that your lines are muted by us. And that's to help reduce background noise while we're doing the presentation. If you have a question, you can raise your hand or you can use the questions box. We won't be monitoring the chat, but we will be monitoring the questions box, and that'll be one of Quentin's primary jobs. If you would raise your hand in the session, which is you should have a little icon for doing that, then we'll try to get to you. We'll unmute you at that point, and you can ask your question verbally. But other than that, feel free to answer or ask your questions in the questions section of the GoToWebinar interface there on the panel, and we'll be answering them as quickly as we can. So this webinar is recorded, and the recording will be available on our YouTube playlist as well as on our Enterprise Customer Success Hub. And so all of the sessions that we've done with the Plant 3D community meetups and other community meetups are all recorded and posted there, as well as the questions and answers that are posted during those sessions. So you can download those in Excel format. All right. So first off, my name is Joel Harris. I'm a designated support specialist here at Autodesk. I've been with Autodesk for, it says 5 years there. I need to update this slide. It's actually been almost 7 years now. Some of the products that I support are Plant 3D and P&ID, of course, as well as the Navisworks and Recap. I've been working with Autodesk as a designated support specialist, but prior than that, I was a process piping designer. And I'm here today joined by my colleague, Quentin Contreras. So Quentin, can you introduce yourself?
Sure, thanks, Joel. So my name is Quentin Contreras. I am a technical support specialist here at Autodesk. I've been with the company going on over 8 years now, mainly supporting Plant 3D, P&ID, but also core AutoCAD, electrical, Vault and BIM, and Navisworks. Those are mainly primarily towards the workflow that are related to Plant 3D mainly. Prior to Autodesk, I originally from Texas, so I worked primarily in the oil and gas industry, doing various drafting, design work out in that area. That's a little bit about me. Back to you, Joel.
Thank you, Quentin. All right. So today we're going to cover first off our agenda. We'll start out with an overview, and we'll give you a little bit of news on Plant 3D, as well as the topics shown here. And then we're going to get into this month's theme, which is really an introduction to 3D blocks for custom parts and catalogs. Typically, we do a sort of a brief introduction on these topics. the overall agenda that we have here usually takes about 45 minutes or less, and that's kind of our goal is to give you a little bit of time before your next meeting. But depending on the number of questions that we have, we'll try to get as many of those in as possible. So, and we'll have time for that open discussion and Q&A. But feel free to ask questions anytime during the session. This is our monthly virtual meetup. That's what we're doing right now for the Plant 3D user community, and each session is intended to be a casual engagement. So we do put together some material to share with you, really kind of a catalyst for discussion and questions. But we are open for any sorts of questions and discussions, except for the non-technical roadmap type questions. Both Quentin and I are technical support people, so we're not in the product team. We're not the product managers or the developers, so we're limited on what we can share. But hopefully the discussion will still be useful to you. It's driven by your content and your questions. But on the safe harbor statement, this is a lot of legalese, but really, in a nutshell, reminds you that if we do speak of any, future updates or stuff that are coming, that's possibly on the roadmap, you should always verify that with your salesperson, your Autodesk salesperson, or your channel partner, to make sure that your understanding of the features is correct and that those features are still available, because things change and product scope changes, and we don't want to talk about something that's not released and then have it not come out on the product. So just make sure that you understand that before you make any purchasing decisions. And let's go ahead and begin. Let's talk about some Plant 3D news. Should mention too here that AU happened just a couple weeks ago in November before Thanksgiving, and there are all of the on-demand and live recordings are available for AU. It includes some Plant 3D classes. So it's autodesk.com/Autodesk-University. And there's even a FAQ there if you have questions about AU, say 2021, next year, what's going to happen. And we show an example answer there of a FAQ there, but feel free to check that out. And Quentin, I don't know if you wanted to post that link in the chat there. That'd be great for everybody to be able to access.
Yeah, I can do that.
Thank you. Right. So that AU, hopefully some of you were able to participate in that. I know that I was a panelist on an AutoCAD Plant 3D Q&A panel, and that was real fun. We got to do it with a couple of my colleagues in Germany. We had several other AutoCAD Plant 3D classes that were of interest there, as well as all the other products and workflows and industry talks. So a little different this year. We didn't get to see anybody, but hopefully you were able to attend and to get some benefit from that. And it is available, like I said, online, even after AU. All right. I don't see any questions, so I'm going to go ahead and go to the next slide. And those of you who did join us at Autodesk University probably learned a little bit about our group network. The Autodesk Group Network is a global network of user groups, developer groups, and online groups. You can join a group to connect with others, to learn, build relationships, share your knowledge. And the network includes both physical and online virtual groups. You can filter by product or industry, your language or location to find out more about that group, and click out to the homepage to get involved. So I'm excited to announce that these monthly meetups are transitioning over to that platform. So the Plant 3D meetup that we're in right now won't be happening in January. We're taking a break after December to reflect on the past year and how to offer you an integrated community experience, better connecting you with our user group community, who are the people that are on this call along with you. And so once the details of the new Plant 3D meetup are all set, we'll post more information to the community dojo. And Quentin, I don't know if you can post that link into the chat, that would be great. Yeah, so that's the Autodesk Community Dojo.net. link. And the Community Dojo is also a great place to learn more about building community groups if you want to build one yourself, and connecting with the Autodesk Group Network program. So we're enabling you to do that. Good, thank you, Quentin. That link is there for the 2021 meetups. And then also, if you wanted to watch any recordings of any of our past meetups, you can always go to customersuccess.autodesk.com, and there's a meetups link there too. So, and Quentin has put that in the chat as well. So thanks so much, Quentin. So that's our news right now. And don't see any questions quite yet. So we'll go ahead and start into the technical part of the session with discussion about 3D blocks for custom parts in catalogs. And we would say catalogs in the title here, but it's also just custom parts in general. So what is 3D block-based content? Well, that's the topic of what we're talking about today. And it's really typically custom parts are generated from 3D solids. At least that's the recommended workflow. They might represent valves, fittings, instrumentation. They're usually created in a catalog or directly in project drawings. So there's two ways of doing it. And this is what you would do, say, for example, instead of using the Python script generated geometry that comes from the catalogs in Plant 3D. Those are limited to the Python scripts that we have, or any custom Python scripts that you've created or that you've purchased through catalogs or downloaded from the Autodesk App Exchange store. Really, we have the typical cylinders, spheres, those sorts of things. But if you have more complex geometry and you want to use a block library that you've maybe downloaded from a vendor, you can actually do that with your catalogs, as well as ad hoc when you're designing in Plant 3D. So as you can see here, you've got 3D shapes. If you create blocks out of them, that's going to be the workflow that we're going to show you here, and name those blocks by the size that's appropriate, because these are not parametric, these are just static blocks. You can use that in Plant 3D and they'll have a live connection and be an intelligent object. So, all right. So why create 3D block-based content? Well, there's going to be cases where you're unable to locate the required parts for your project through the App Store, say downloading a pre-made catalog. And you might be able to create a catalog with descriptive information for those parts, but you may not have the capability or the time to create your own Python scripts, or the Python scripts that come with the software, which you can see here in the catalog builder. The various shapes, the parametric graphics that we have there don't represent your part correctly. So if that's the case, but you do have block-based geometry that you can access, or you can create those with AutoCAD, then that would satisfy that need. Then you'd probably go that route instead. So how would you go through that process? Well, here's just an overview, quick overview. If you're doing 3D block-based content for your catalog components, which are going to be more for permanent catalogs, you're going to take your 3D blocks, which you download from your vendor, or you're going to model them yourself, convert those blocks to plant parts using the plant part convert command. So if you originally have just AutoCAD solids, then you'll need to create blocks out of those, and usually each block will have its own name that will include the size, the nominal diameter of that part, and maybe even its rating if it's a flange component or has a different rating, and some descriptive information so that you know when you're managing many of these blocks, having them named properly and stored in a particular drawing that's stored along with your catalog is a really good idea. And then you can convert those to plant part convert, which is where we add the metadata that works with Plant 3D, which is the port locations and directions for the ports. And then once you've done that with the plant part convert command, you can actually use the catalog editor to create that new component, which is going to have all the descriptive data. And then it will go out and allow you to pick that block and define the port and component properties. So let's just see if I've got this up here. So if I'm in the catalog editor here and I want to create a new component, you have the basic part family options here, and it shows you these are the actual categories that would help it sort and filter in the catalog. So if I'm looking for say a valve type of part, and then you can pick whether it's going to be a valve or valve body. A valve body would be something which you then could associate a TopWorks with, or operators. And then you can pick best your primary end types. Let's say if I have a flanged valve there, and I can pick my size range. So let's just go from 1 inch to 1.5. It's a very small range. I'm going to go with my imperial sizes here. If I can't find the shapes that are available in the parametric scripts that are shown here, these are our parametric graphics that come with Plant 3D, I can pick a custom AutoCAD block-based graphics. And this is where I'm going to tell it how many ports are on the, I don't know why it lost that, probably because of my sizes. Nope, I don't know why. Oh, because I changed there. All right, so when I changed to the graphics, block-based graphics, it lost some of that up that I had up above. But yeah, so you pick your connection ports for this type of part, and then you're going to say create that. It's going to go ahead and ask you to pick the drawing, ask you to pick the blocks for the different sizes and go through that process. I'm not going to demonstrate that here, but I just wanted to show you where that is in the catalog itself so that you understood what we're talking about here is building a catalog, but having those blocks which are external to the catalog, and they're not stored along with the Python scripts as your geometry that's going to be used. So when you put those catalog parts in a piping spec and then put them in your model, it can actually find those blocks and bring them in and apply the intelligence and all of the descriptive data from the specs and catalogs. So that's that process. The other process is your one-off or ad hoc placeholder components where you have a block, you're not waiting for the catalog, or you're not able to get the catalog modified and the spec modified to be able to place that from the tool palette. So instead, you just bring the block into your model, which you can once again bring in a solid, make a block out of it, and then you use the plant part convert command to actually convert that block to a plant part. And then on the Plant 3D ribbon, there's a Plant Custom Parts command, which will allow you to define the port and component properties. And this is actually within the software. So if I'm going to open up a model here, let's say if I had a block in here, I don't have one in here, but the Plant 3D part creators over here. Yeah. Okay. Let's see it. Excuse me. There we go, custom part. So Plant Custom Parts is the command. And when I pick that, it's going to ask me to either use a Plant 3D shape, which once again is coming from the shape browsers. I can specify from the same libraries that were in the catalog, the part library that I want based on, is it a cap? Is it a, what is it as far as a part category, and what's the end type? So you have the different families or parts up here, so we can do like we did before in the catalog. I could pick valve and then browse to the shapes. But you also have the AutoCAD block option here, where I can choose the block from this model right here, because you might have just inserted in temporarily to create it as an intelligent object, or import the block from an external drawing where the plant part convert command's been done on those drawings. And then it's going to create that AutoCAD block-based part. So, and then here's your text parameters that would be part of typically in your spec or catalog. And then you can insert it in the model afterwards. So this is where that lives in the Plant 3D ribbon. And that's this Plant Custom Parts command that we just showed you. So those are the two methods for generating block-based geometry in Plant 3D. There are some tips, best practices that we'd like to share with you, as well as part of this webinar. So I'll stop right now before just to see if there's any questions, Quentin, that came in that we need to address.
There was one question that came in, but I did send a response to that one, and I think you're going to cover some more
Okay.
particular for that question in the next couple of slides
Okay.
here.
Great. Thank you. All right. So talking about the tip number one here, which is use existing or new 3D models. When you're locating and converting vendor content, we do recommend that any 3D models that you use, you can convert to AutoCAD solids. If you do get a mesh, don't just use that. Typically, meshes are the bane of AutoCAD's hidden line removal algorithms, which are used for orthographic generation in Plant 3D. They cause a lot of problems because of all the triangle faces, typically that are used to generate something like a curved surface. They'll cause slow performance or just no performance when you're trying to generate orthographic drawings if you have too much of that. So really, if you can convert them to AutoCAD solids using Inventor, that would be a recommended way to do it. That bringing something into, say, Navisworks and exporting an FBX file and then bringing that in and converting to an AutoCAD solids is going to, it may be easy. And just because you can do it doesn't mean you should do it, because you'll end up with performance problems later on down the road when you generate your orthos. But if you're going to import it into Inventor, we do recommend that you do some shrink wrap substitute inside of Inventor. And there's videos out there and AU classes on that. Good documentation on that process. Really what that is so that you can reduce the amount of the level of detail that's in the Inventor fabrication level of detail model to bring it to a design level of detail for AutoCAD and for your 3D models there. You can imagine if you have hundreds or thousands of parts and you're showing all the nuts and bolts and embossed manufacturer stamps on every cast part, that's going to slow AutoCAD down at some point. So you can see an example here where you have a, looks like a check valve. It's basically got a bunch of nuts and bolts, stud bolts holding the cap on the body. That's not necessary for clash detection typically, clearances, or even for rendering an appearance unless you're trying to do something that's photorealistic. When it comes to doing plant design with Plant 3D, we would recommend a lower level of detail for better performance. So that process down below of shrink wrap, substitute, even remove the holes from the flanges. Those are not necessary. We don't need to count the number of holes in Plant 3D. Matter of fact, you probably won't even see them. So any internals, like the port there, if this was actually a manufacturer's model, the Inventor shrink wrap substitute will remove those internal details and make it something that you can see on the right, which is more appropriate for Plant 3D. And if you do model something with Inventor using iLogic parts, or use the shrink wrap substitute, the last two options there, you do want to export to DWG as solids because you have that option of doing a solid or a mesh. Make sure you've selected solids when you export to DWG, and then you can bring it into Plant 3D, convert it to a block, do the plant part convert to add the ports, and then add it to your either your catalog or using the ribbon to make it an intelligent Plant 3D object. So 3 files that are created when you use the plant part convert command is the XML that's actually is going to contain that pipe port information that we talked about, where you're adding the location and direction for those ports. There's a snapshot that gets created so that it can show up in the catalog editor. Also, it'll show up on the tool palettes if you add it to a spec. So that PNG image is out there, that thumbnail image. And then there's the DWG file. Now this DWG file is going to have a GUID or GUID name. So it won't have the same name as the block that you created inside of your drawing. But it does exist outside of that with a GUID that's linked to the catalog if you're creating it in the catalog editor. So the XML and PNG are created in the same folder location as the original DWG. And all 3 files are required for the catalog editor for the custom parts command. So if you were to say share a catalog with somebody, knowing where these files are is really important. So we'll talk about that. So the XYZ location of the port and the direction it faces are stored in the XML file. And so that's really an important file too that I kind of glossed over that, but it is an important file to have. So with tip number 3, support files for catalog parts. This is what I kind of mentioned in the last slide, is that you should maintain those initial paths used for the catalog creation. So wherever your shared content folder is kind of your basic location for all your catalogs. And then underneath that will be the various catalog types, like the ASME catalogs, your custom catalogs, AWWA catalogs that ship with the Plant 3D software. And then under that, maybe you've got your support folders. So you can see here that the default location for the custom blocks for catalog is going to be your shared content folder, which is AutoCAD Plant 3D, say 2021 content, and then CPAC, which is your content pack, and then it might be ASME there. And then underneath that's going to be your catalog name with a catalog, the word catalog after it, and that'll be the folder. And then typically we put your DWGs there. So that would be the DWG that contains all the blocks that you're going to include in the catalog. And there is actually an AKN article here, which sort of explains that, where the custom blocks are stored and saved for catalogs. And this explains it right there. So if you need this reference, it talks about that same content you see on the screen. So an example folder structure here is, with the AutoCAD Plant 3D 2021 content, which is your shared content folder. Underneath that is a particular catalog. It says it's pointing to that catalog folder, and it says that's the PCAT file. The PCAT file is typically going to be living inside of that folder. And then under that will be a catalog folder, which might be called My Custom Parts Catalog, that we recommend that you put your DWG file that has all of your drawings. And it's also will contain the 200 folder, which is where the PNGs are going to go, and the DWG folder, which is where those GUID renamed DWGs for each block are going to go. And that's what's going to be inserted into your 3D model by the spec later. Okay, any questions so far, Quentin? I'm hoping that I'm not going over people's heads. I talked about this being a basic thing, but I know some of you have probably gone past the basics, so hopefully this is good. Any questions?
I've got 2 questions. I have a user asking, is it possible to add a piping item from a spec to a catalog?
Well, I've never gone that way. So if you have a spec building a catalog from the spec, it sounds like, because in the case of what we're talking about here with block-based geometry, the block-based geometry's got to come from a catalog into the spec for the spec to be able to use that. So, so I'm guessing you must be talking about being able to generate a catalog part from a spec, and I have not done that, Quentin. I don't know if that's possible to do. It seems like with Catalog Builder or through the Excel export import, you should be able to do that.
Yeah, I actually was looking myself, and I did find a previous forum post that kind of talks about using it for a valve. I'm not sure if it'll work for a pipe though, so I sent a response, and so refer to that forum link and see if that works.
Okay, yeah, good. Well, thanks. Yeah, that's a process I've never done where it went from a spec back to a catalog. But in the case of, like I said, 3D block parts, the 3D blocks will be stored with the catalogs. So your specs are typically part of your project, your Plant 3D project, and so they will live in a different place, but they'll look back to your shared content folder to get that catalog reference, which the spec has knowledge of what catalog was used to build it. And in that catalog reference will be the GUID, which it uses to find the DWG and the image, so that you can actually insert that part, that 3D block part. You said you had another question too, Quentin?
Yeah, we can get to one more. I think there's a couple of more that are coming in, but we'll get to this one and I'll let you continue, Joel.
Okay.
So the next question is the CPAC folder prefixed used for anything?
It's just an abbreviation for content pack, meaning that that's what ships with the product. If you were to get from the Autodesk Exchange store another catalog downloaded. It may not have that CPAC prefix. It's not really required. So it's just something that our team here that develops our content sort of named all of their content packs that way. And I'm going to do something ad hoc, which you're never supposed to do in these sessions, but I'm going to go ahead and pop up my shared content folder just so you can see it, and you'll recognize it because it's going to look just like yours. Let's pop it over where you can see it. So you can see I've got just the content pack that comes out of the box with Plant 3D. And if I was to go to, say, the ASME content pack, you'll see in this location there is a PCAT, which is actually the catalog file. This is a SQLite format database. And whatever the name of that catalog is, you'll have a folder with the same name there. So it's like if I have my ASME Valves catalog PCAT folder, it's going to have also a ASME Valves catalog folder in the same location. This is what we recommend for you to always have. It gets created that way automatically. There's also a bunch of specs that come out of the box that ship with the product. We can ignore those because those are not necessary. But if we look at this PCAT, we'd open that up in the catalog editor. It's a SQLite file, like I said, and then you have your folder. Here's where your images would be. And this, like say the 200, this is where you're going to see all the images that will show on the tool palette or in the catalog editor. And there would be a DWG folder created here automatically if I was to add block-based content to the ASME Valves catalog. We recommend you kind of leave the out-of-the-box stuff, that you get as far as catalogs go, untouched. And if you're creating a custom catalog, create your own catalog. And that way you can store and share and manage that. And if you do update your Plant 3D in the future, and we add a bunch of stuff to the Valves catalog, you don't lose all that or overwrite your changes when you update with the new catalog. So keep your customization separate if you can. That includes catalogs. And note that there would be a DWG folder here if I had any block content that was part of my ASME Valves catalog. So, all right, so continuing on. Tip number 4, drawing units and scaling. We've had people submit support tickets where they will have downloaded a bunch of geometry from a vendor, and that vendor might have created all that geometry in metric units. And so we recommend that when you create the blocks from that, make sure that your drawing units are set appropriately and that you've scaled up the blocks or the geometry first to the right size before you start making blocks, because the blocks will read the insert scale from your drawing units. And that's really important for Plant 3D. So if you're building 3D block content for imperial projects, you want to go with architectural lengths and inches for the insertion scale. And with metric, you're going to want to go with decimal length units and millimeters insertion scale. And this is important because unlike just regular Plant 3D Python-based geometry, block-based geometry is specific to the units that they were created with. So even though I could take an ASME catalog and use it in an imperial project or a metric project, if it doesn't have block-based geometry, if it's just Python scripts, I can do that. But if I've got block-based geometry, it's got to be, it's basically a units sensitive. So, right. And see, we got our technical reference. Here is a great class by one of my trusted colleagues who happens to be in this session with us. So we have an expert in the house, folks. Quentin Contreras' Autodesk University class. You can see him right here. If you're building a pipe it with AutoCAD Plant 3D, and this does talk about the plant part convert process there, and something that I recommend that you do. This is an AU class that's online and it's available for you. It's from last year's AU. And that's, once again, autodesk.com, Autodesk University, and you can just search for Quentin Contreras if you want to. He's got a lot of classes he's taught over the years, and or you can use the link from the PDF, and I think that you've actually put that in the chat too, didn't you? Thank you.
Yes, I put it in the chat.
Yeah, awesome. And then also you shared the Hagerman link there too in the chat, and that's one of our partners. We're not favoring a particular partner. This just happens to be one partner that wrote a blog that covered creating a custom instrument catalog using block-based geometry. So all of our partners are valuable to us, and we love the work that they do. They are oftentimes a source for a lot of our customers' custom catalogs out there, whether it's support catalogs, pipe support catalogs, or instrumentation catalogs like this one here. Um, they're they're probably the biggest source of a lot of the content that gets created out there outside of just our customers themselves. So, all right, so there's that's pretty much our technical reference for this um, meeting, and just wanted to say at this point we have our open discussion and Q&A. So let's go ahead and see if there's any more questions that we can answer in the chat or in the questions. You have any, Quentin?
Yeah, I got one for you. So one of the questions that came in was, and this is for the tip that you showed, number 3, says you are creating a new catalog folder and not using the catalog support folders. What are the differences or benefits?
Well, first you'll have to make sure that you are pointing Plant 3D to your shared content folder. So under here, for example, modify shared content folder can be done here. And I'm going to show you what happens if you don't have administrative rights, or if you haven't launched the program with administrator rights, you'll get this error message. So, for me, I can relaunch the Plant 3D spec editor. If I can find it on my other screen here. Hang on a second. And I'll run it as administrator, which is a right click. And then when I run the Plant 3D spec editor, and I'll drag it over to my screen so you can see it, I can go to the tools and go to modify shared content folder, and it will show me that now. So I have administrator rights on my computer. I relaunch the application with those rights enabled, as administrator, and now I can see that shared content folder. This is where it's looking for all your catalogs. So you can't have some catalogs here, some catalogs there. For Plant 3D to work, it's going to have everything that you're using in one location. Now, it's true that you can actually have specs built with catalogs in other locations, but if those catalogs are in other locations and they have block content, it's going to come back to here for that block content, typically, my experience. So we recommend that you keep everything in the shared content folder, because there's some stuff that's customizable like this path, and there's some stuff that's hard-coded to the software as far as where it looks for parts, where it looks for some of the scripts and the variants zip file, for example, for the Python scripts. It's all got to be there in that shared content folder. So if you have your own shared content folder and your own catalogs, that's fine. They don't have to be where I'm showing it right here, as long as you've got those variables set in the registry using either this command as an admin, or if your deployment of Plant 3D sets that variable. Then it's going to look there for your content, and then underneath your whatever custom catalog you have, if you have your own, your own content, it might be, ABC Corp content, and then you'd go to that folder and you would find all the different catalogs there and the different catalog folders. So you might have your 20 custom catalogs for your company that you use, all the PCATs, and then a folder for each one of those PCATs, which is your catalog. And inside of that folder is going to be all your images, which are automatically generated from the plant part convert command, and also the DWG folder that would be created, and also the DWGs that contain the blocks that you want to sort of manage with that catalog folder. So hopefully that describes what I was asking for, or what I was explaining earlier with that folder. Even if it's custom, you still need to have your DWG folders there. We see a lot of support cases where people say, well, I got this catalog from, Jim, and I can't, it's giving me, no images on my tool palette. Well, that's because you didn't have the blocks and the DWG files in that subfolder that we're looking at right there. That needs to be shared along with it. See, now for me, I could zip up this catalog and this folder knowing that's all I need for that catalog, because inside of this folder is going to be all the DWGs and the source DWG file that had all the blocks in it. And then I don't have to worry about managing my catalogs in all these different places. So hopefully that was a good enough shotgun explanation there. So how about any other ones, Quentin?
Yeah, I got a couple more. We got a little bit of time here. So, kind of to follow up on that previous question, they were asking if you use Plant Modify Shared Content folder to place your shared folder on a network path, will your custom block support files still work as intended?
Yeah, they should. They might be a little slower just because you are accessing across your network, but it's not going to be, that noticeable unless you've got a huge content library with a lot of blocks. It's just kind of like Design Center in AutoCAD. It depends on the speed of it being able to generate all the images for your previews inside of the tool palettes and software. So we've seen people with slow networks out there, customers with slow networks, put all of their custom blocks and catalogs on their network drive. But then when they launch Plant 3D, it takes a while for it to load those tool palettes, or if they change specs in the ribbon, it's got to reload that tool palette with all those images. So, and as you saw, there's a lot of images that are in that support folder for that catalog, all of the different resolutions of the images, and one for every GUID-based name. So this is like the part family is cross. There's that GUID name there, and that's the rest of the PNGs. So, so every block you create is going to have these PNGs created for it. So that's all going up on your network. But yes, that's probably the most common workflow that people have, is it's stored on a network drive where it's accessible. If you have problems with your network, then the next thing is when you log in, your users log in, there's a login script that copies down any updates to their local shared content folder. And you've got basically a daily update, and that's how accurate their local, faster shared content folder drive would be. So, next question.
Okay, and you might have answered this in what you were saying earlier, but let me go ahead and say this, put this one out there. Is there any way we can get Plant 3D to look for the common folder on, let's say, for instance, a shared drive or network drive? Having it on your C drive is a bit of a hack, especially when new PC come into play.
Yeah, no, totally understand that. And that's just part of the architecture of Plant 3D is limited by the constraints of the way it's set up. The common one, let's just go back to that CPAC common, because that's where you're going to have your nozzle catalogs there. Let's just sort them by type here so you can see them together. You got your actuator catalogs, nozzle catalogs, all your structural support catalogs are there. You also have your custom parts catalogs are there. And then you got this variance map file and a metadata zip file. See how big this zip file is? It's huge. And the variance zip file, there are actually tens of thousands of files in there with all the scripts describing, how to draw the different geometry. And so what we find is using like a cloud sharing solution or a network drive, sometimes it became, impractical for all of that geometry to be able to be, or all of those files to be able to be stored in that. We're seeing though these days with cloud storage becoming more normal and network performance is being better in general, that people are able to do more of that. But I haven't seen anything that's really saying we're going to change this right away. So you kind of are stuck with this CPAC common being part of your shared content folder and being in a place where these files, especially these folders that are zipped up that contain thousands of uh, files in them, are in a place where it can be accessed quickly. So you can't split it off to a different location. So, but it's a great thing for the idea station. If you wanted to submit some of these ideas of where you think would be work better with the software, whenever they go back and in the development teams and look at changing the way certain parts of the program run. They do go out to the idea station and capture as much of what they think they could include in that, what they call a sprint of development, so that they can, not just fix one thing, but fix several things that are all related. So, and if it's a feature request that you have, that's definitely something that you can take advantage of. So that's the idea station in the forums, and those are at the forums.autodesk.com, or the Autodesk Knowledge Network is another place to go, which is knowledge.autodesk.com. All right, I think we got time for one more question, and then we're at 45 minutes, so I'll probably close it down after that. So.
Okay, so for the last question, user was asking, I was trying to create a spec for a project, and while I was creating it, I found that the ASME catalog was not complete. Does it proceed?
Well, I can't guarantee that every ASME, every fitting that's covered out there by ASME is in that our ASME catalog. It's the pipe and fittings catalog is going to have a pretty, comprehensive but not complete. There may be some, Y fittings or laterals or, street Ls that you're going to find that are, they're covered by ASME, but they're not in our catalog. You can certainly add more ASME to the ASME catalog, but once again, you run the risk of if you upgrade to a newer version of Plant 3D and you want to use new things that we've added to the catalog, you're going to have to sort of parse yours out, export them out, and re-import them into the new Plant 3D catalog that you got there. But yeah, there's an entire possibility that you're going to see AWWA or ASME catalogs coming from us that are not going to include all of the content covered by that particular engineering code. So our content teams available. They're there for if you have any questions. I'm going to quickly pop up before we leave the Plant Content Center. So let's just go ahead and see if I can bring that up here so you can see it. Let's go to the Exchange apps. So this is where you'll see a lot of Autodesk plugins from our partners that have developed stuff. And if I go to Plant 3D and go to Catalogs and Specs, this is apps.autodesk.com. It's our app store. You'll find not only the paid ones that you would get from that other people have developed, like this tube fitting ones. There's actually cable tray catalogs up here and such, but there's also the ones from Autodesk. So you can search based on publishers, but another way of just looking is page through this right here, and you'll start to see these icons right here. This is all of the Autodesk generated content. So if you wanted to look at the George Fisher parts, which are your CPVZ parts, you'll see here that customer support is plant.content@autodesk.com. This email is great if you don't have a normal support channel that that you rely on, but you did find something in the content that you want to report back to us, or a gap in the content. You can certainly email plant.content@autodesk.com, and our developers monitor that and will review those emails coming in to see if there's trends or if there's stuff that they need to fix. So this is how you would reach us when it comes to content questions. So, and with that, I'll go ahead and get back to my presentation here and just say thank you very much for this year of the Plant Community Meetups, and we hope to see you next year when we start up the ones with our groups, the Autodesk Group Network, and we'll have these questions that you asked and the answers, as well as this recording, posted to the customer success.autodesk.com site. Thanks again, everybody.